Hello everybody. There was a boy named Samir. Once recently, he was very hungry. So he thought of ordering a pizza online. He ordered a large 14-inch pizza on his mobile and got an instant estimated delivery time by the app of 40 minutes. The pizza store confirmed the order and started the preparation of it. They used math to prepare the pizza. Using the formula of area of circle, they determined the amount of dough needed. The area of circle is pi times the radius squared. So for a 14-inch pizza, the radius is 7 inches and the area of pizza is approx 154 square inches. Then they used math to calculate the amount of sauce, cheese and toppings needed based on the size of the pizza. Meanwhile, the delivery boy who was waiting outside the store, he used math to calculate the time required to reach the destination. He knew he could bike at a speed of 10 miles per hour. So he calculated that it would take him 25 minutes to reach the destination considering the traffic on the road. The pizza got ready and was delivered in time to Samir. We often use math in our daily lives without even knowing it. But we often see people fear learning math and they find it difficult to cope up with it. In this video, we'll try to clear all the doubts and try to lessen the fear so that everyone aspiring to become a data scientist benefits out of it. So, what are we waiting for? Let's get started. I recently conducted a poll on LinkedIn and Twitter to know which part of mathematics is relevant from current industry workers. We got a good response for it. I first thank you to the data science community for giving such a good response. But as I stated earlier, many of us still have a fear of maths as a subject. Even I had in some point of my life. But when I started relating math as a subject to our real world, believe me guys, it became an exciting journey for me. I still remember, I used to raise my hand first to give the answers in our class of algebra in 11th grade. There used to be a competition amongst our class students who shout out the answer first and help our ma'am to fetch the correct numbers. It was pretty exciting time. Now, while learning data science, I want you guys to focus on 3 main topics and try to relate it with the real world while learning it. In data science, I would highly recommend you guys to learn statistics. This is a field which would be your first stop while working with data in your company. Learning stats will help you know what your data is, how well it is dispersed, do hypothesis testing and get predictions done on it. Statisticians are highly paid people in many of the companies. I have seen few companies who are specifically looking for people with PhD in stats. They earn more than a doctor these days. But apart from salary and its perks, it's the basic thing to learn, those who want to make a career in data science. Knowledge of random variables, probability distributions, hypothesis testing, statistical inference. Believe me, this knowledge can be used in any domain you work for in analytics. So, in stats, I want you guys to focus on descriptive statistics. Descriptive statistics is used by data scientists to summarize and describe the main features of a dataset. For example, measures of central tendency, such as mean, median and mode, can help provide a summary of the average or typical value of a variable in the dataset. Inferential statistics. Data scientists use inferential statistics to draw conclusions about a population based on a sample. Inferential statistics can help answer questions such as whether a particular variable has a significant effect on another variable, or whether a particular trend is statistically significant. Regression analysis. Regression analysis is a statistical technique used to model the relationship between a dependent variable and one or more independent variables. Data scientists use regression analysis to make predictions and to identify which variables are the most important in explaining the variation in the dependent variable. Hypothesis testing. Data scientists use hypothesis testing to test whether a particular hypothesis about a population is supported by the data. Hypothesis testing can help answer questions such as whether a particular marketing campaign is effective or whether a new drug is more effective than an existing treatment. Bayesian statistics. Bayesian statistics is a branch of statistics that deals with probability distributions and their applications. Data scientists use Bayesian statistics to make predictions and to estimate the uncertainty associated with their predictions. Then comes our second topic, which has gained relative importance with the advent of machine learning and AI. Linear algebra. Linear algebra is very important when we are creating models while doing machine learning. Knowledge of linear equations, matrices, vectors will help you understand the science behind the models. This is very essential for you, being a data scientist or a data analyst. Guys, one who understands the science of what's happening and why it's happening will always stay ahead in competition. Creating models is relatively easy, but to understand the logic and the picture behind the scenes, this is where you'll gain a competitive advantage. For example, there's a topic called principal component analysis and dimensionality reduction, which is widely used while working with models. Having linear algebra knowledge, you guys will be able to find what are the principal components of a given dataset using linear algebra techniques. In linear algebra, focus learning on vectors and matrices. You should have a strong foundation understanding of vectors and matrices, including basic operations such as addition, subtraction, multiplication and division. Matrix operations. You should be familiar with various matrix operations such as transpose, inverse and determinant. These operations are important in solving linear equations, calculating eigenvalues and eigenvectors, and performing various other calculations. Systems of linear equations. You should be able to solve systems of linear equations using matrix algebra, including Gaussian elimination and Lie decomposition. Vector spaces and subspaces. You should understand the concepts of vector spaces and subspaces as they are extensively used in data science and machine learning. Linear transformations. You should be able to represent linear transformations using matrices and understand its properties, such as injectivity, surjectivity, and invertibility. Eigenvalues and eigenvectors. You should understand the concept of eigenvalues and eigenvectors, as they are used in various machine learning algorithms, such as principal component analysis, singular value decomposition, SVD. We should understand the concept of SVD, which is used in various applications such as image compression and collaborative filtering. Then comes our last topic, calculus. This topic I know many of us have learned during our college and engineering days. Knowledge of derivatives and its theorems was a boring thing that time. But see what? We live in a world of artificial intelligence, where calculus is used extensively, generating neural networks. There is a concept called backpropagation. We'll be learning it in upcoming videos. It is used massively while building neural networks. We use chain rule and derivatives to compute gradient descent for a loss function. I could relate its importance now while learning neural networks and AI. This topic has gained a lot of importance with the increase of data with companies. In this calculus module, I want you guys to focus on limits and continuity. These concepts are fundamental to understand calculus, and they are essential for understanding many statistical concepts like conversions and approximation. Derivatives. Calculus is widely used in data science for optimization problems, and derivatives are the key to finding the maximum and minimum of a function. We call it maxima and minima. Integrals. Integrals are used for computing probabilities, for finding areas under the curve, and for solving optimization problems. Multivariable calculus. Many problems in data science involve multiple variables, and multivariable calculus is essential for understanding these problems. Differential equations. Differential equations are used to model many real-world phenomena in data science, such as population growth and the spread of diseases. Now, you might be wondering how much of each of these math skills is required to learn data science. The answer is that it depends on what area you want to specialize in. Let's say, for example, if you're interested in learning or to be in natural language processing, you might need to have a deeper understanding of probability and statistics. If you're interested in computer vision, you might need to have a stronger background in linear algebra. Now, no matter what area you want to specialize in, it's important to have a good understanding of all the math skills listed above. You should aim to have a strong foundation in all of these areas before moving on to more advanced topics. In conclusion, I can say a strong foundation in maths is essential for learning data science, artificial intelligence, and machine learning. While you don't need to be a maths genius, you should have a good understanding of the concepts like linear algebra, calculus, probability and statistics, optimization, algorithms, and data structures. It's important to remember that the amount of each of these math skills required to learn data science depends on what area you want to specialize in. However, a good foundation in all these areas will give you a strong grounding to build as you learn more about these exciting fields. Thank you for watching this video. We hope you found it informative and helpful. If you have any questions or comments, please leave them below.